So, hello guys, let's check the next exercise. It's called merge to sorted lists. It's easy level. So let's check the conditions. So you are given to sorted single linked list in ascending order, and we need to merge them into one sorted linked list and return its head. And below you can see that we have some examples. The first example, we have list with values 1, 2, 4 and null, and the second list with values 1, 3, 4 and null. And in the end, like output, we should to have these two lists to be merged and also sorted. So that's the condition. Now let's visualize our algorithm and understand what actually we need to do in order to reach and to solve this task. So you can imagine that we can have two lists, list 2 with values 1, 3, 4 and list 1 with values 1, 2, 4. And the first step which we need to do is to create a dummy node. Why we need this dummy node? Because the next element to which this dummy node will indicate will be the element from our merged linked list. Yes, why we can't use the head of list 1 or list 2, because we don't know initially which element is less, from the first list or from the second list. So because of that, we create the dummy, and the next element for that dummy will be the first element from the merged list. The second thing is to create another pointer, another variable in other words, which in our case I named tail, but you also call it like current element, because actually tail indicates to the current element for the current iteration. And the next thing which we need to do is to compare first elements from the both lists. Why first elements? So how it was mentioned in the condition, these lists are already sorted and we want to merge them. And in the result, we will have a list with these values merged and also sorted. And because of that, because these lists are already sorted, it means that the greatest element is on the end and the smallest on the beginning. So we need to compare these two elements and to check which is less. So we compare 1 with 1, we can see that they are equal. So let's say in that case, the first element will be 1 from the list 1. And the next step, we just repeat, actually the next step, we need to change the pointer tail to indicate to the next element, which is 1. It will be the, let's say, the current element for the next iteration. And that's it, and in the next iteration, we just repeat these steps which we already have seen. So again, we check which element from the beginning of a list 1 and list 2 is less. In that case, it's 1. So the tail will point to this element. So we are doing so. You can see that now this tail is pointing to this element. And the next step, we need to change the pointer tail to point not to this bucket, but to the new bucket added in our merged linked list, let's say. And we repeat this process until the moment we merge our lists. You can see all steps here. So that's a visualization how algorithm should work. So in next step, let's check how we can implement this in the code. So let's implement this logic. So let's start, and first of all, let's create the signature of our method. So public static we will return the node. It will be the head of our merged linked list, and let's call our method merge. And like argument here, we will take two arguments. The first one will be the head of the first linked list, and the second one will be the head of the second linked list. Perfect. Now let's create the dummy object. Let's put here 0. Actually, the value is not important here, but we need to set, because we have a constructor with a parameter value here. Okay, and let's say that initially the tail will be equal to our dummy. Yes, because the next element of the dummy will be the first element which we compare between these two lists. Yeah, for example, list 1, the first element from the first bucket is 1. Here, let's say it will be 2. We compare them, we see that 1 is less than 2. So the next element of a dummy will be the bucket with value 2 from the list 1. Yeah. Okay, and now let's create a while, because we need to iterate somehow. And what will be the condition? The condition will be that we will iterate until the moment list 1, so the element from the list 1 or element from the list 2 is not equal to null. Because if it's equal to null, it means that we already iterated through all elements from one list or another. Which means, for example, if let's say in list 1 we have 5 elements, but in list 2 we have only 2 elements, it means that we will make just 2 iteration minimum. Yeah, so we will add these 2 buckets somehow in the new merged linked list, but let's say the rest elements from the list 1, because in the list 1 we have much more elements, 5 but not 2, we just will put at the end of a linked list. I hope it's clear. So the condition will be, so we iterate till that moment, then list 1 is not equal to null, or list 2 is not equal to null. Yeah, it means that we still have some elements in list 1 or list 2, so we need to continue to, actually we have elements and in the list 1 and in the list 2, which means that we need still to iterate, because we need to check which element is greater or less, and to put in the correct place in our new merged linked list. Okay, now we need to put here a new logic which will make this comparison. Yeah, so we need to check which element, which value is greater from the list 1 or from the list 2. So we need to write something like that. So list 1 value, if it's less or let's say equal than value from the list 2, it means that dummy, actually not dummy but tail, next element, next node, will point to this bucket, yeah, from the list 1. And then we need to iterate to the next element, and for that we just do something like that. So now list 1 will point not to the first element from the linked list, but to the next one. List 1 next value, next node. Yeah, perfect. If, for example, list 1 value is greater than list 2 value, it means that we need our tail next node to point to element from the list 2, and then we need to move to the next element. So we are doing something like that. So list 2 is equal to list 2 next value, next node, sorry. So perfect. And in the end, we need to write something like that. So tail is equal to tail dot next node. Yes, because we also need to move our tail to the next element. Okay, perfect. And the last thing which we need to do is what do we have here? Okay, maybe it will fix when we will finish our code, so we will see. So the last thing which we need to do to check, for example, let's say our while will stop, yeah, because let's say elements from the list 2 points to the null, but we still, let's say, have elements in the list 1. It means that all elements from the list 1 we need just to put in the end of our merged linked list. Yes, but for that we need to check where we still have some elements. Yeah, so let's say if we stopped here, so if we stopped to iterate in that while loop, it means that somewhere we don't have any more elements and we need to find out where. So we check, for example, if list 1 still have some elements, it means that all these elements we need to put in the end of our merged linked list. So we are doing something like that. Tail next node is equal to list 1. Yeah. Otherwise, else tail next node will point to elements from list 2. Okay, perfect. I think that's it, and in the end we need to return the head of our merged linked list, and the head will be dummy dot next node. Yes, so we need dummy for that because somehow then we need to find the address to the first element of our merged linked list, and this address will be stored in dummy.next node. So for that purpose we created this dummy variable. So that's the solution. I hope it was clear and useful for you. So we will see you in the next video. Bye.